You know that feeling, right? That little flash of insight, that aha moment when a brand new idea just seems to pop into your head out of nowhere? Well, that's the spark of human creativity. And for literally centuries, it's been one of the biggest mysteries out there. So let's get right into it. This is the big question, isn't it? Artists, inventors, scientists, philosophers, you name it, they've all tried to figure this out. Is it some kind of magic? Is it just divine inspiration? Or is it something we can actually break down and understand? And what's so incredible is that we're not just talking philosophy anymore. Science is actually starting to peel back the layers of this mystery, getting closer and closer to mapping the very mechanics of how our imagination works. Okay, so how in the world do you put something as slippery as creativity under a microscope? Well, what researchers are doing is they're breaking it down into smaller pieces, components they can actually study, test, and believe it or not, even replicate. To do this, scientists are basically coming at it from two main directions. The first is computational, which is all about trying to simulate the creative process itself. The second is cognitive, and that's focused on modeling what's actually happening inside our minds. Let me put it another way. We can try to build a creative mind using things like computers and AI, or we can try to map the creative mind by studying how our own brains pull it off. They're two different lenses, but they're both pointed at this same amazing phenomenon. All right, let's start with that first lens. The computational approach asks a really massive question. Can we actually engineer creativity? Is it possible to write code that comes up with a truly original idea? And the answer seems to be, yeah, we're getting there. Researchers are developing all these fascinating models that can mimic human creative thought. They're using techniques like metaphorical reasoning, blending totally different concepts together. They're even using models inspired by quantum physics and neural networks to simulate how our brains link up ideas. Now, here's a really wild theory. It suggests that creativity exists on a spectrum that's defined by the signal-to-noise ratio in our neural networks. Get this. When that ratio is low, our thoughts become looser, more associative, and that's where you find creativity. Or, in extreme cases, even psychotic functioning. A higher ratio, on the other hand, leads to more rigid, structured thought. It's a stunning idea that connects our brain's very chemistry directly to our creative genius. This whole idea of associative thought brings us to another powerful concept, the autocatalytic network. Now, that sounds super complex, I know, but the basic idea is actually beautiful and simple. I want you to imagine your mind as this huge, sprawling network. Every single memory, every concept, every idea you've ever had, it's like a little point of light floating around in there. So when you focus on just one of those ideas, let's say coffee, it doesn't just sit there by itself. It instantly triggers a bunch of related ideas. Morning, warm, beans, energy. And that sets off a chain reaction. One idea sparks another, which sparks three more, creating this incredible cascade of free association. And it's somewhere in that chaotic, self-fueling web of thought that completely new combinations and truly original ideas can just emerge. Okay, let's switch to our second lens now and see how this all connects. If the computational lens is about building a creative process from scratch, the cognitive lens is about mapping the one that's already humming away inside our skulls. So how does a creative mind actually work? Psychologists have kind of broken it down into roughly 3 steps. First, you have to represent the problem in your head, right? Maybe you reframe it from being a wall to being a door. Second, your brain dives deep, accessing a super wide and diverse range of memories and ideas. We're talking everything from a documentary you saw last week to a song you heard years ago. And then third, and this is the magic step, you compose those existing pieces in a way that's never been done before. Our brain has a few key tools it uses for this. You've got mental imagery, our ability to not just see things in our mind's eye, but to actually spin them around and manipulate them. Like how Einstein imagined himself riding on a beam of light. Then there's counterfactual thinking, that simple but profound act of asking, what if? That question is behind pretty much every invention ever. And finally, there's the idea of conscious thought itself as a kind of simulation, a mental sandbox where we can test out the wildest ideas with absolutely zero real-world risk. And this is what makes human imagination so incredibly powerful. We don't just simulate what's possible. We can literally dream up impossible worlds. We can imagine fire-breathing dragons or spaceships that travel faster than light, things that have no basis in reality but are completely real inside our heads. This super flexible simulation engine, that's the true playground of creativity. So we have these two really different approaches, building the machine versus mapping the mind. But the real breakthrough, the really cool part, is when you realize they're not competing with each other. They're two halves of the exact same map. And looking at them side by side really makes it clear. The computational lens is all about exploring how creativity could work, often using AI to build out examples. The cognitive lens, on the other hand, studies how our creativity does work by looking at tools we all use, like mental imagery. So one builds a simulation while the other models the reality. The big takeaway here is how these two lenses create this powerful feedback loop. You see, the insights from cognitive science help us build better and better computational models. And then, trying to build those models forces us to ask much sharper questions about how our own minds really work. It's together that they start to give us a much, much clearer picture of imagination. So, why does any of this matter? Why are we spending so much time trying to decode our own imagination? Well, because understanding the source of our creativity is really about understanding a core part of what makes us human. To really get why this is so important, let's jump in a time machine. We're going to go back about 50,000 years to a moment when something absolutely incredible happened in our evolutionary history that changed everything for our species. All of a sudden, we see this cultural explosion, this insane acceleration in art and tools and complex societies. The leading theory is that this was triggered when our cognitive abilities finally crossed a certain threshold, one that allowed us to invent and combine abstract concepts in brand new ways. Our creativity literally changed the entire course of our species. And that brings us to one final, really powerful question. If we are finally, after all this time, beginning to truly understand and even model the cognitive spark that ignited our entire past, what does that mean for our future? What new tools, what new societies, what new ideas can we design when we can not only use our imagination, but actually understand it?